On October 17, 1944, deep inside a German technical evaluation depot outside Kassel, a battered American M3 half-track was rolled off a flatbed truck and pushed into a dimly lit hangar. No one there knew it, but that ordinary vehicle, scratched, muddy, and peppered with bullet holes, carried inside it a secret the German war machine had never seen before. Outside, the Third Reich was collapsing. Inside, German engineers gathered with clipboards and flashlights, expecting to confirm what they had always believed: American equipment was crude, simple, and inferior. But the moment they opened the half-track, they froze. What they discovered inside that steel hull did not just shock them, it terrified them. This script tells the full story of what they found, why it mattered, and how one vehicle revealed America's biggest wartime advantage. On October 17, 1944, the late afternoon light slid through the cracked windows of a German research depot, illuminating floating dust that shimmered like flakes of ash. The war had entered a grim phase for Germany. The Allies were pushing from the west, and the Eastern Front was breaking apart. Supplies were dwindling, cities were burning, morale was fractured. Yet even in this chaos, the Wehrmacht still believed one thing with unwavering confidence: German engineering was superior to anything the Americans could build. That confidence would not survive the day. Hours earlier, a convoy had arrived from the front lines, delivering a captured American half-track found abandoned in the Ardennes region. It had been dragged through mud and shell fire. The left side panel was cracked open where shrapnel had flayed the metal. The interior smelled of oil, gunpowder residue, and wet canvas. To the German soldiers who recovered it, there was nothing remarkable about the machine at all. But to the scientists and engineers waiting for it, this was treasure. They had spent years analyzing American military equipment, trying to understand why the United States could produce so much, so fast. Germany's factories were stretched thin, relying on specialized parts and complex designs that demanded skilled labor and long production windows. The Americans, on the other hand, seemed to manufacture vehicles in endless waves: half-tracks, Shermans, trucks, jeeps, so many it felt like every destroyed one was instantly replaced by two more. The Germans were desperate for answers. Somewhere in American machinery, hidden inside its structure or wiring or armor, they believed a secret existed, a secret that explained American industrial supremacy. Now they finally had a fresh specimen, nearly intact. The M3 half-track was hauled into a service bay and propped up on wooden blocks. The depot was silent except for dripping water and the occasional echo of footsteps from the adjacent hall. Two engineers, civilians with wire-rimmed glasses and worn notebooks, circled the vehicle slowly, inspecting it the way a jeweler might examine a sacred gem. Others followed with calipers, small lamps, and sample trays. A young assistant wheeled in a trolley filled with tools. At first glance, the half-track looked crude: flat plates, bolted seams, rivets everywhere. To a German eye trained on precision, it almost seemed messy. But beneath that surface, something odd began to emerge. The bolts were identical across different sections. The weld patterns matched internal framing supports. Electrical connectors snapped into standardized sockets. Fuel lines ran in a clean, almost modular pattern. To the Germans, trained to see inconsistency in foreign machines, this level of uniformity was unsettling. They removed the first armor plate and leaned in. Instead of custom-machined components, they found mass-produced parts, stamped, molded, interchangeable. A hinge from the driver's door could fit onto the cargo compartment. The steering column could be replaced without modifying the housing. Even the stabilizing brackets, which in German vehicles were specially shaped for individual chassis, were the same from front to back. Silence fell. Pens stopped. Eyes narrowed.
This machine was not built like a weapon, it was built like a product. One of the senior engineers, a former automotive designer from Mercedes-Benz, scribbled into his notebook and muttered under his breath. He ran his fingers along the chassis bracket, then walked to the opposite side and touched its twin. Gleich, he whispered, identical. It was this realization that began to unsettle the group. Identical parts meant interchangeable parts. Interchangeable parts meant rapid assembly, rapid repairs, and rapid replacement. Machines like this did not require armies of machinists or specialized metalworkers. Anyone with a wrench and a basic toolkit could fix one.
Another engineer lifted the hood and stared at the engine bay. What he saw contradicted everything the German automotive industry believed in. German engines were masterpieces, tight tolerances, precision components, delicate alignments. But the American engine looked like a machine built to survive anything: dust, mud, snow, neglect, even bad mechanics. Parts that would normally be hidden under layers of custom fittings were exposed and easy to reach. Bolts were standardized, wiring was neatly routed, plumbing was straightforward, almost elegant in its simplicity. The discovery sent a ripple of discomfort through the room. If the Americans could build half-tracks like this, then maybe every vehicle they produced followed the same principles. If so, it meant something far more terrifying than superior design. It meant superior production. The German engineers began removing individual components: brake drums, crank housings, steering linkages. Each piece that came off the vehicle told the same story. Nothing was handmade, nothing required fine-tuning, nothing needed specialized parts. It was as if the Americans had designed the machine not for perfection, but for repetition, hundreds of thousands of repetitions. For the first time that day, the engineers exchanged glances that revealed something unspoken: fear. In the middle of a war that Germany was rapidly losing, this half-track was telling them why. Meanwhile, outside the depot walls, Allied bombers droned overhead in distant sky corridors. The city trembled with explosions. The war was not waiting. Factories were being pulverized, supply lines were collapsing. Yet inside this quiet room, German scientists faced a revelation far more destructive than any bomb. They continued dismantling the vehicle, now focusing on the transmission housing. The gearbox was sturdy, uncomplicated, and easy to disassemble. The gears themselves were not exotic alloys. They were standard steel, heavily produced, and yet they worked. Where German gearboxes demanded constant lubrication and tight adjustments, this American example seemed built to shrug off abuse. One engineer shook his head slowly. It was almost insulting. Germany prided itself on technical superiority. Its tanks were masterpieces. Its equipment was refined. But that refinement came with a deadly weakness: complexity. German vehicles were glorious on paper, deadly on battlefields, but nightmares in factories and repair shops. Every breakdown demanded specialty parts. Every replacement part required skilled labor. The half-track sitting in that German depot was the opposite. It did not seek perfection, it sought reliability, and reliability came from simplicity. The team returned to the interior, and this was where the shock truly hit. The wiring harness, the arteries that fed power through the vehicle, was modular. Entire sections could be detached and replaced without dismantling the whole system. The fuse box used standardized connectors. The ignition switch was compatible with other American vehicles. Even the dashboard components looked mass-manufactured, as if they'd been pulled from a common bin. That was the moment the truth became impossible to deny. The secret hidden inside the half-track was not one component, not one tool, not one material. The secret was a system built on standardization, interchangeability, and industrial scale. The Germans had uncovered the core principle of American wartime power. The United States fought with factories. Not soldiers, not strategies, factories. And those factories had learned to build war machines like consumer goods, fast, simple, interchangeable, replaceable. As the engineers stared at the half-track's exposed interior, the magnitude of their discovery settled in. They were holding physical proof that America could outproduce them forever. No matter how many vehicles Germany destroyed, America could build more. No matter how many tanks Germany knocked out, America could replace them instantly. One engineer closed the notebook he'd been writing in and exhaled heavily. He knew what the others knew. Germany was not facing an enemy defined by technology. It was facing an enemy defined by scale, a scale no nation on earth could match. The room had gone quiet again. Tools rested. Voices faded. The half-track sat open, gutted, silent, a mechanical messenger revealing an uncomfortable truth. Germany was losing not because its machines were inferior, but because the American machines did not need to be superior. They only needed to be unending. Outside, sirens wailed. The depot's lights flickered. Engineers exchanged stunned looks. What they found in that half-track would soon spread through German analysis networks and echo across command channels. It would reshape German automotive planning, alter military expectations, and confirm their darkest suspicion. They had no answer to American production. And yet, the most shocking discovery still hadn't been made. The engineers had not yet reached the compartment beneath the floor plating, the compartment that held the true secret, the one that would explain how the United States was able to maintain total consistency across every military vehicle it built. They were about to remove those panels. But first, they needed to steady their hands.
The engineers stepped back from the half-track, the exposed engine still glistening under the harsh yellow lamps that hung overhead. The air inside the depot felt heavier now, as if the walls themselves understood what had been uncovered. The team had already seen enough to challenge every assumption they held about American craftsmanship. Still, the real work had barely begun. The section beneath the floor plating remained untouched, and older reports from captured vehicles suggested that the Americans often hid crucial systems there. Wiring conduits, transmission connectors, power distribution lines, and sometimes even secondary coolant systems were placed beneath the steel footpan. The German engineers believed this area might finally reveal what they had been trying to find for years: the truth behind American standardization. Two men crouched near the driver's seat and began removing the bolts that held the floor plates in place. Their tools clanged against the metal, echoing through the room. The plates resisted removal at first, fused to the frame by months of moisture and debris. After several minutes of straining and hammering, the seam finally cracked and the first panel lifted away. What lay beneath caused the lead engineer to freeze mid-motion, his breath catching in his throat. Instead of the usual chaotic tangle of wiring and tubing expected inside most combat vehicles, the underfloor compartment was astonishingly clean. The wiring harness was positioned in parallel rows, wrapped in heat-resistant cloth, organized into a color-coded channel that snapped into anchors along the frame. The cables weren't simply routed, they were designed to be installed without hesitation or confusion, a feature that spoke directly to mass manufacturing. Next to the wiring, 3 modular junction boxes sat in perfect alignment. Each was stamped with the same serial pattern. Each was removable by hand with minimal tools. Each box connected to the next using identical copper terminals.
The engineers stared in silence. This was no accident. This was not improvisation. The Americans had deliberately engineered every part of this machine so someone with ordinary skills could replace anything quickly and efficiently. In the chaos of war, time was often worth more than steel, and the Americans had clearly decided to save it everywhere they could.
One engineer picked up a junction box and examined the rivets holding it together. The workmanship was not graceful. It was plain and industrial, built for speed. But it was also durable, the kind of thing that almost never failed. And if it did fail, the crewman could swap it out in minutes. The man holding the box shook his head in disbelief. If German vehicles broke wiring internally, repairs were nightmares. Panels had to be removed, housings opened, specialized tools fetched, and technicians trained. But here, inside this American half-track, the entire system could be replaced like a child's toy construction block. They continued removing more panels. Beneath the next section lay the identical layout, and beneath the next, and beneath the next. Every inch of the vehicle was designed for uniformity, as though some assembly line far across the Atlantic Ocean produced these machines in perfect rhythm. The realization struck them all at once. This was only possible if the Americans were building everything, not just half-tracks, but tanks, trucks, jeeps, artillery tractors, everything with common internal architecture, common parts, common dimensions, common tools. It was one thing to talk about mass production. It was another to see it manifested physically in a machine taken straight from a battlefield. The half-track was proof. The oldest engineer among them, a man with white hair and trembling hands, leaned back against a workbench and stared at the ceiling. He had spent 30 years designing engines and vehicle frames for German industry. He understood what he was looking at better than anyone else in the room. Germany had spent the war designing masterpieces, Porsche Tigers, Panther tanks, self-propelled artillery, each a marvel of precision craftsmanship, each one requiring armies of machinists and colossal amounts of time. But this American half-track had revealed a brutal truth. The United States had embraced an entirely different philosophy. Instead of building masterpieces, they built quantities. Instead of focusing on perfection, they focused on production. And that difference was killing Germany. Outside in the depot courtyard, dusk had spread across the sky. The distant rumble of artillery fire echoed from the western hills, the bad news of war continuing to close in. But inside the depot, time seemed suspended as the engineers documented everything. Notes were scrawled feverishly, sketches filled multiple pages, dimensions were measured, connections were traced. Nothing in the half-track resembled German construction. Nothing required precise calibration. Nothing required the hands of a master craftsman. The chief designer tapped the wiring channel with his pencil and whispered that this sort of design philosophy changed everything. Not just production, but logistics. If every part on every vehicle fit every other vehicle, then the Americans could move supplies like clockwork. Repair units carried one style of bolt instead of 10. Factories stamped thousands of identical components and shipped them east. Every damaged half-track could receive the same spare parts from the same distribution chains. Meanwhile, German armored units were paralyzed by delays. Tanks sat abandoned, not because they were destroyed, but because a broken gear housing or misaligned pinion needed a factory-made replacement. Engineers knew this, soldiers cursed it, commanders feared it. But the problem had never felt more real than it did now, staring at a disassembled American vehicle. More panels were removed, more discoveries emerged. The fuel pumps were modular, the brake lines were routed identically, the suspension mounts were standardized. Even the bolts securing the armor plate were matched to bolts inside the dashboard. Each revelation felt like a blow. Germany believed its complexity made it superior. Instead, complexity had become its prison.
After hours of disassembly, the engineers finally reached the most sensitive section, the stamped coding that revealed manufacturing data. Here, beneath the driver's floor,
Polished steel tags were riveted to the frame, marking where the half-track had been produced. The team leaned in close, eager to know the name of the factory responsible for such a machine. But what they read shook them more than anything else they had discovered. It wasn't a factory code. It was multiple factory codes. The half-track hadn't been made in one plant. It had been made in several. Parts came from different factories, different regions, different companies, and yet everything fit together with perfect alignment. The notes confirmed it. The half-track's frame was stamped in Pennsylvania. The wiring was from Michigan. The transmission assembly connected to a production line in Illinois. The armor plate was cut in Ohio. Germany had never considered such a possibility. The idea that dozens of factories could collaborate, building interoperable pieces that integrated without modification, was staggering. It was industrial symphony on a scale the engineers could hardly understand. One man lowered his notebook and stared at the half-track in horror. If the United States could coordinate factories like this, then their capacity was effectively limitless. There were no bottlenecks, no shortages. A factory bombed today could be bypassed tomorrow. A plant destroyed in one state could be replaced by another hundreds of miles away. Germany didn't have that luxury. And the terrifying truth was this: the Americans weren't even close to running out of resources. The engineers continued working into the evening. At midnight, the depot fell silent as the team paused to eat and rest. They sat on crates and against walls, staring into space, each lost in thought. The clang of distant artillery drifted like thunder. But what haunted the men most was not the war outside. It was the industrial monster across the ocean. One man finally broke the silence. He whispered that what frightened him most wasn't American engineering. It was American simplicity. Germany had assumed the Americans built machines as crude copies of their civilian industry. But simplicity wasn't crudeness, it was strategy. The United States had built war machines like commercial appliances, powered by supply chains that functioned with mathematical precision. The Germans had spent years convincing themselves that their enemies were imprecise, lazy, industrially inferior. But the truth was the opposite. America had evolved beyond traditional engineering. It had embraced an entirely new way of building vehicles, and that way was winning the war.
The chief engineer stood, stretched, and ordered the team back to work. They weren't done yet. There was one final section to examine: the lower chassis, where armor plates met suspension arms. They rolled beneath the vehicle on metal creepers, lamps hanging from hooks. Underneath, the story remained the same: standardized bolts, standardized connectors, standardized mounts. But then they found the most shocking detail of all. Stamped into the frame, hidden beneath grime and grease, were alphanumeric codes that linked directly to production dates and assembly lines. These weren't military stamps. They weren't technical part numbers. They were consumer-grade tracking codes, the kind used in civilian automotive factories. It was proof that the half-track was not built in a specialized wartime facility, but in ordinary car plants converted for military use. That meant something devastating. America hadn't even mobilized its full industrial potential. It was winning the war using factory systems designed in peacetime. The United States could build even more vehicles, far more, if pushed into total military production. The realization rippled through the engineers like a chill. Germany had strained every last resource just to survive this far, but America was holding back. The youngest engineer looked up from beneath the vehicle, oil smearing his cheek. He asked the quiet question no one wanted to say aloud. If the Americans built half-tracks in car plants, what were their true war factories building? Silence followed, heavy and absolute. In that moment, the engineers understood the full weight of the secret beneath the half-track's steel floorboards. America had not only mastered mass production, it had weaponized it, and the Germans were powerless to stop it. Yet still, the most important discovery, the terrifying one, waited ahead. For in Part 3, the engineers would uncover the hidden markings that explained exactly how America made its vehicles identical across all factories, across all states, across all production lines. The true secret had not been revealed. Not yet.
The depot lights hummed through the early hours of the morning, flickering slightly as the power grid strained under the weight of a wounded nation. Outside, the city lay in uneasy silence, waiting for the next siren to break the night. But inside the workshop, the engineers were wide awake, energized by discovery rather than rest. The half-track sat elevated on service blocks, stripped open like a dissection specimen, its mechanical organs exposed to the cold air. Pages of notes lay scattered across tool chests and tabletops. The men were exhausted and shaken, yet determined to continue. The chief engineer gathered his team around the frame and reminded them of their purpose. Their mission was not simply to examine a captured vehicle. They were trying to understand why Germany was losing the war. This half-track was more than steel and rubber. It was a message from across the ocean, a physical explanation of American warfighting power. Knowing that, none of them were ready to stop. Not yet. By 3 a.m., they had dismantled nearly every component except for a sealed bulkhead chamber beneath the rear floor. The panel was welded along its edges, suggesting it was never meant to be opened by a typical repair crew. The engineers debated whether to cut through it, as opening a welded compartment risked damaging whatever lay inside. But the lead designer insisted it had to be done. If there was any area in the half-track capable of revealing the true core of American production, it was this one. They brought over a small acetylene torch, sparks spitting into the darkness as the metal softened, split, and curled back. The smell of scorched steel filled the air. When the final line of welds gave way, the panel dropped loose and echoed across the floor. What remained inside that hidden compartment instantly commanded every pair of eyes in the room.
It was a set of stamped plates, perfectly aligned, coated in grease to prevent corrosion. Each plate was embossed with series numbers, alignment codes, blueprint references, and what appeared to be calibration instructions. At first glance, they looked ordinary enough, but then the engineers noticed something extraordinary. The stamps were unlike anything they had ever seen in a military vehicle. They were not identifying a specific part, nor a factory, nor even a production batch. Instead, they described compatibility. Compatibility across platforms, across models, across industries. The chief designer took one of the plates and read the sequence aloud. The code was structured in a way that immediately conveyed meaning. By referencing a single chart printed on the reverse side of the plate, the technician could determine the compatible part replacements from numerous American vehicles. It listed half-track transmissions interchangeable with truck transmissions, troop carrier pistons replaceable with artillery tractor pistons, and multiple engine families capable of sharing identical components. This was beyond impressive engineering. It was beyond logistics. It was beyond manufacturing. It was standardization at a scale the Germans had never even imagined. One of the younger engineers whispered that this was the true secret, the key to everything. The half-track itself wasn't special. It was simply one node in a gigantic industrial network. America wasn't just producing vehicles in enormous numbers. It was producing vehicles that shared DNA. That meant spare parts were universal. Factories backed each other up. Repair teams could service any machine in the American arsenal with the same sets of components. Germany could build 1,000 tanks and still lose the war because the Americans could repair theirs faster.
Germany could field elite armor and elite artillery and elite vehicles and still fall behind because each American loss meant nothing on the production scale.
Another engineer knelt beside the compartment and brushed dust and grime from the bottom. Beneath the grease lay one more set of codes, a sequence that seemed almost impossible to believe. These numbers referenced not just production compatibility, but design compatibility. They indicated that American vehicles had been intentionally structured years before the war to share the same engineering foundation. The realization settled like a slow fog. America had not adapted its industry to war. War had adapted to American industry. Every German in the room understood the implications. The Americans had spent decades building a manufacturing ecosystem powered by consumer economics, not military necessity. Everything from automobiles to refrigerators to farm equipment had been designed around interchangeable parts, modular assemblies, and national supply chains. When war came, the United States did not need to learn how to build half-tracks because the country already knew how to build cars. It did not need to learn how to build tanks because it already knew how to build engines. All the Americans had done was convert their civilian industrial power into wartime output, and they had done it with terrifying ease. Germany, by contrast, had believed that the war would be won with complexity, innovation, and precision. They had built the Tiger tank, a masterpiece of design, but a nightmare of production. They had engineered Panther tanks, brilliant machines that required armies of skilled laborers to maintain. They had created wonder weapons, experimental technology, and elite systems that dazzled military observers, but broke down faster than they could be repaired. No standardized parts, no shared platforms, no interchangeable production. The truth hit them all at once. Germany had never stood a chance. The chief engineer rose slowly, feeling the weight of the secret settle onto fragile shoulders. He said nothing at first. Then he spoke quietly, as if confessing a truth that had been buried in the German psyche since the beginning of the war. They had assumed that American equipment was inferior because it lacked elegance, but simplicity was not inferiority. Simplicity was victory.
The man worked into dawn, documenting every plate number and manufacturing sequence. They charted the codes and compared them to the other systems they had seen. The pattern emerged clearly. The half-track was not a miracle. It was standard procedure. The Americans had thousands more like it, tens of thousands, and they would all perform the same way. When daylight finally slid through the cracked windows of the depot, the world outside seemed strangely quiet. The war, for a moment, felt distant. The engineers stood around the half-track, exhausted, stunned, hollowed out by what they had learned. No one wanted to reassemble the vehicle. No one wanted to close the panels or hide the truth. The half-track looked less like a machine and more like a warning, a messenger from the Allied factories across the sea. Last evening, when they had first opened the underfloor compartment, they still believed that the war could be won by strategy or bravery or technological superiority. But by sunrise, they knew the truth. Germany was being crushed not by tactics or firepower, but by manufacturing philosophy. American industry had scaled beyond anything the world had ever seen. It was not a matter of quality versus quality. It was quality versus quantity at impossible scale. The report was finished by noon, 50 pages long, detailed sketches, measurements, production analysis, psychological assessment. The chief engineer signed his name at the bottom of the final page, but his hand shook as he wrote. The document would be copied and distributed to military and industrial leadership across the Reich, but everyone in that room knew the truth. The analysis would change nothing. Factories could not be redesigned. Supply chains could not be rewired. Vehicles already in production could not be retrofitted. The war had already decided its outcome.
Outside the depot, distant artillery rolled again. The city shook. The front lines were closing in. Soldiers marched through the streets with exhaustion carved into their faces. Civilians huddled in basements, listening for the whistle of falling bombs. And unseen above the clouds, American factories continued pouring machines into the world. New half-tracks, new tanks, new trucks, built with the same invisible codes that made repair effortless, replacement immediate, and production limitless. In the final hours of daylight, as the engineers prepared to leave, one of them lingered beside the stripped hull. He placed a hand on the cold steel and tried to imagine where the half-track had been, what battles it had fought, what men had driven it, what countryside it had crossed before falling into German hands. He wondered whether the Americans who built it had known just how important it would become. Perhaps not. To them it was just another vehicle, one of thousands, one of too many to count. He stepped back, staring quietly at the shape of the machine. The room's silence swallowed him. And then he understood. The real secret was not in the codes or the wiring or the interchangeable parts. The real secret was in the mindset. America believed that war was not won by outthinking the enemy, but by outbuilding them. It believed victory belonged not to the most intricate designs, but to the ones that could be made over and over and over again. That was the revelation that rattled Germany to its core. Not that America built machines better, but that America built machines differently. The man turned and walked away. The half-track remained where it was, silent and open, its secret no longer hidden. It had traveled from a battlefield in France to a warehouse in Germany, not knowing that its true purpose was not to carry soldiers or supplies, but to carry truth. A truth the engineers would never forget. And as the depot doors closed and the sun dipped behind the clouds, history moved forward, carrying with it the echo of that discovery. The war was not yet over, but the outcome, written in steel beneath the floor plating of an American half-track, had already been decided.